Welcome you all to the Spark Research YouTube channel. This is Dr. V. Chandra, Assistant Professor in the Department of ECE, and this is the another session of this course, Analog and Digital Communication, and we are going to take the questions which has been asked in GATE 2022. Particularly, we will focus the questions which is related to the unit first and second. Right? So let's go ahead. So here is the overview of your analog and digital communication. So in this session, actually, we are going to take the questions particularly from this analog and digital analog communication, particularly from the super heterodyne type of the receiver, right? So let's take the question now. So question is that consider in an FM broadcast that employs the pre-emphasis filter with frequency response H pre-emphasis of omega is equal to 1 plus j omega divided by omega naught, right? So here the j omega is variable, as here it is given omega naught is known. So what is that value of this omega naught? The known one. So omega naught is 10 to the power 4 radian per second. For the network shown in the figure, in this figure, to act as a corresponding de-emphasis filter. So this is the corresponding de-emphasis filter corresponding to this pre-emphasis filter. So we have the transfer function of this pre-emphasis filter, and corresponding to this pre-emphasis filter, de-emphasis circuit is given. Now question is asking the appropriate pairs of RC, the values of R and C, right? So first of all, we have to understand that this question belongs to the FM broadcast. Definitely, actually broadcast means whenever we are talking about the broadcast means transmitting and receiving, that exactly the transmitter and receiver, that is super heterodyne type of receiver you may consider, right? Okay, so here whenever we will look, actually we have to find out the resistance and capacitance of this dim phase circuit, but there is no any other informations are available in this question related to the dim phase circuit. Whatever the information is given, that is related to the pre-emphasis circuit. So this is the twist here. So whenever we like what are the parameters are given, so in your pre-emphasis circuit we have the transfer function along with the known frequency, right? So first our target is to how can we find out the values of resistance, capacitance. So first we must have to find out the value of the transfer function, right, for the dim phase circuit. Then only we can find out the values of R and C or the combinations. Here actually they are looking for the appropriate pairs, right? So then only we can establish. So in order to do so, we have to find the transfer function so that we can find out the the relation with the RNC, that is the well-known frequency. So that is our target. So how we'll do? So your options are given, and as per answer key, your answer A should be correct. That is R is equal to 1 kilo ohm and C is equal to 0.1 microfarad. Okay. So here is the idea about the pre-emphasis and de-emphasis. You may think that what is this pre-emphasis and the de-emphasis. So this is nothing like pre-emphasis we are using in the modulating side, right? Means transmitting side. So whenever we are transmitting the information, we are using pre-emphasis, right? So that will boost the high frequency. So here you can see high pass filter is being used here, right? So high pass and low will suppressed. So this is the pre-emphasis filter. Objective is to boost the high frequencies. So in this transmitter, this is a transmitting station, like person is telling something and you are going to listen. So if you are a listener, then you are using a radio. So here is your receiver. So that is in the receiver side we are going to use dim phase circuit along with the demodulator, definitely, right? So dim phase circuit, what will do, it will reduce the high frequency, and then suppress the low frequency, right? So like if you will check it properly, then here in the pre-emphasis circuit it will boost the high frequency, and in de-emphasis circuit it will suppress the high frequencies, means the transfer function will be the reverse to each other. So this is the actually the relation that we have to understand here. So pre-emphasis and the de-emphasis are the just reverse. both will have the reverse transfer function, right? So we'll use this technique. Okay, so let's go ahead in the technical, some more technical detail. So this is the transmitter here. Now here the pre-emphasis, that is h of p, and the modulator, right? And this is the transmission channel, and then demodulator, that is receiver side. So demodulator, and this is your de-emphasis circuit transfer function. And then finally you will have the message. So here is your voice signal, and here is the channel, that is air, and here is your again reconstructed voice signal using the FM channels. Like now, here is the circuit for pre-emphasis circuit. So that may includes the resistance, capacitance, and resistance, and the corresponding, this is the transfer characteristic. So you can see here high frequency is passing. So omega 2, if it is greater than omega 2, it will pass very quickly, and if it is in between omega 1 and omega 2, it will pass with certain loss, and it will suppress if it is lower than omega 1. Similarly, this is the de-emphasis circuit here. So RNC is here, and this will the acts like a low pass filter. So low, for low frequency it will pass, and for high frequency it will suppress, right? So just reverse. So here let's dive into the details of the transfer function of this pre-emphasis circuits. Then you may understand it a better manner. So h of p of omega, for this only we are targeting to find out the transfer function for this pre-emphasis circuit. So k of j omega plus omega naught omega 1 divided by j omega plus omega 1, right? And here you can replace k is equal to omega 2 by omega 1, that is gain only. So you can replace kp omega is like k, just you can replace value of k, and for omega very less than 1, it will cancel out to each other, and h of p omega will be equal to 1 if omega is very less than omega 1 in this region, right? So no frequency will pass. For frequencies in between this in this region, that will be equal to j omega divided by omega 1. Why? Because omega 2 will cancel out, and your omega will also will be almost can be removed. So j omega divided by the omega 1 it will be. And so this is about the pre-emphasis. And for de-emphasis circuit, for this one you will have the omega 1 this one divided by the j omega plus j omega 1, right? So here interesting factor is that, what is the interesting factor? Like here, for omega less than omega 2, right, in this circuit, for pre-emphasis, if we'll check, if omega is less than omega 2, in that case what will happen? H of p omega, means h of p omega, this one will becomes j omega plus omega 1 divided by omega 1. Why? Because here now omega 2 into j omega plus omega 1 divided by omega 1 and j omega plus omega 2. So omega is very much less than omega 2, right? So omega 2 and omega 2, it will cancel out, and then omega 1 is remaining, and since omega is very less than omega 2, so omega can be neglected. So finally we get the j omega plus omega 1 divided by this omega 1, right? So this is the case for pre-emphasis circuit. And if you will check the reverse, so this de-emphasis, in the case of the de-emphasis circuit, if you will make it reverse, then you will get this transfer function, right, which we have obtained for de-emphasis circuit. So that is why h of p omega into h of d, that is the transfer function of pre-emphasis circuit means this, and transfer function of de-emphasis circuit means this, will be equal to 1, right? So in our question we are going to use this technique in order to find out the transfer function of the de-emphasis circuit, as the transfer function of pre-emphasis circuit is given. So we'll use this analogy, right? Okay, let's go now. So in our question, the this circuit is given. So circuit belongs to the de-emphasis circuit now only, because there is no parallel. Okay, so now so this condition we are going to use, that is pre-emphasis transfer function de-emphasis is equal to 1. So pre-emphasis circuit transfer function is given, that is 1 plus j omega divided by omega naught in our question only. So for de-emphasis what will be? It will be just reverse. So 1 over divided by 1 plus j omega divided by omega naught, right? So now we got the transfer function of the D emphasis circuit. So this transfer function is given in our question, and now we have to find out the transfer function of this D emphasis circuit. And once we will find the circuit D emphasis transfer function for this, then we'll equate and then we'll arrange the values. That's all, right? So let's calculate the transfer function for this. So for this transfer function will be this, what will be the reactance in S domain. We can write 1 by S, no, the S into C. So here I am writing 1 over j omega C for this, and divided by the total reactance, that is R plus 1 over j omega C. So it will be 1 over 1 plus j omega RC. So this is the transfer function of this D emphasis circuit, right? And transfer function already given in the question is this one. So now let's equate this with this. So we'll get the RC equal to 1 by omega naught in order to make it equal. So omega naught is given in our question, that is how much, 10 to the power 4. So that means RC must be equal to 10 to the power minus 4, right? So in our options, if you'll check, then if you'll choose the option A, then R is equal to 1 kilo ohm and C is equal to 0.1 microfarad. Then in that case, RC, the product of RC will be equal to 10 to the power minus 4 second. So that is why option A is correct. Okay. So that's all in this session. Thank you to join the session. We'll come with some more questions related to the game. Thank you.